Hi, my name's Trevor, and I'm a math and science tutor. And I just wanted to share with you my notes about how to find the domain and range of a function really easily. I know that for me, when I was first learning those things, I would get them confused a lot, and it would seem like kind of an abstract thing. And as I've been tutoring a lot of people, definitely a lot of people have questions about this. So instead of just tutoring it to one person at a time, I'll record a video, and hopefully you get some use out of it. So let me just share my little iPad with you so I can write. Let's see. There we go. Okay, so hopefully you know what a function is and how it works and why we use things like function notation. If that's something that you're not quite sure about, feel free to leave a comment and ask me to make a video about that because I'd be happy to. But I'm just going to assume, for the sake of this video, that you know what a function is. So functions, we often call them f, although you can call it anything you want. It's just the name of it. And then you open parentheses, and then you have the list of inputs or arguments to your function. So f of x, for example. If I have a function like, let's say f of x equals x squared plus 3. Well, for that function, you could basically put anything you want in for x, because any real number squared, we can do that, right? It could be negative, it could be 0, it could be an irrational number like pi, and we can square it. And we can also add 3 to any real number. And so the inputs to this function f of x can be whatever you want them to be. They could be any real number, right? So yeah, the inputs, they can be any real number. By the way, we can say all real numbers with this little symbol, like a fancy looking R, means all real numbers. Now let's look at what we can get out of this thing really quickly. Let's say outputs. Like, what can f of x produce when we put in, whatever input we want to put in for x? Well, I could put in, for example, I could put in a 1 for x, so f of 1, and then I would just substitute a 1 in everywhere there's an x in that function, and that would give me the output 4. Let's try some others. I could try f of 2. That'd be 2 squared plus 3. 2 squared is 4 plus 3 is 7. So let's see. And then I could put in any kind of crazy ones I want, but I want to keep it pretty easy. But I want you to notice, like, I could go the other way too. Like, I could go, let's say, what's f of 0? F of 0 would be 0 squared plus 3, that's 3. What about f of negative 1? That'd be negative 1 squared. Oh, well, that's 1, just like the first one, plus 3, so that's back to 4. And if you remember what your parabolas look like, oops. If you remember what your parabolas look like, this is just going to be a parabola that is shifted up 3 from the parent function of y equals x squared. If that's a thing that you don't quite remember how to do, feel free to ask me to make a video about that too. Leave it in the comments. But we can take a look at the graph of this thing. It's not a super pretty graph. But take a look at that parabola and notice that we've got some examples here. F of 1 is 4. That was this point here. And f of 2 is 7. That'd be 1, 2, 3, 4, 5, 6, 7. It's like, I guess, this point here. Okay. And we've got this f of 0 is 3. That's this point. And this f of negative 1 is 4. Okay. Notice that no matter what we do, no matter what value we pick down here for x, we're never going to get an output for f of x that is anything less than 3. because x squared, the lowest x squared goes is 0. We put in a 0 and we get 0 and plus 3. But anything larger than 0 raises it up, and anything smaller than, we square it, and so it's positive, and so that raises up the value as well. And so no matter what we do, we're only going to get these output values that are greater than 3. So outputs, x has got to be, oh, sorry, that's not quite right. Outputs would be y's, or f of x. Let's see, outputs, f of x, y, that's got to be greater than 3. Those are the only outputs we can get. Okay? So now here's what I want you to remember. The domain is just the inputs. The domain is the set, the collection, all of the inputs that make any sense to put into a function. And like we had talked about for this function, you can pretty much put whatever you want into it. Any real number that you want to put in, you can square it, you can plus 3, there's no problem. And the range is the outputs. That's the things that you can possibly get out if you were to put any of the things that you could possibly put in. It's all the things that you could possibly get out for y, or f of x. And like we talked about for this function, we can get anything larger that we want to, but we can't get anything less than 3. Okay? Cool. So that's domain and range. Domain, all of the inputs that make sense to put in, and range, all of the outputs that you can possibly get out. Okay, so let's see here. Let me see if I can go to something like maybe a little more challenging. So that one, the inputs, they could be anything. But not all operations are like that. Like the squared operation, you can do that to anything. You can add 3 to anything. But they're not all like that. For example, if we were to take f of x equals, let's say the square root of x, okay? F x equals square root of x. I don't need to write that 2 for you. You can't put anything you want into this, right? I could take the square root of 0, that's no problem, that's 0. I can take the square root of 1, that's 1, square root of 4, that's 2, or even any very funky number, like I could take the square root of 7.93, and that's something, I don't know. But I can do it, though. I can get an answer for it. But you can't take the square root of negative numbers, you may recall. If I were to get the square root of -4, at least that's not going to give me a number that is on the real axis. It's not going to give me a real number, okay? So I can't take square roots of these negative numbers when I'm working with real numbers. So the inputs that I can possibly put into this function, remember that's the domain. The domain of this function is just that the inputs got to be greater than or equal to 0. So x has got to be greater than or equal to 0. That's the domain. That's this function's domain. It's the only things that it'll work on are numbers greater than or equal to 0. I can't do it for -1. I can't do it for -4. You can't say what number times what number equals -4. If I'm only allowed to work with real numbers, it won't work. It's 2 squared is 4, -2 squared is still 4. It doesn't work. So the domain is this gotta be, x has got to be greater than 0. And the range, we can think about that one too real quick. So look at the range. The range of this thing, I can look and can say, okay, well, let's go all the way to the bottom side of our domain, meaning x is exactly equal to 0, and then I can get out a 0 for f of x. And so I can definitely get out a 0. And then I can make x bigger, and I get, if x was 1, I got 1. If x was 4, I got 2. If x was 16, I get 4, those kinds of things. And it just goes up from there. And I can get any number I want in between as well. So I can get any number out that's bigger than 0. So the range for this one is also y or f of x, whatever you prefer, has got to be greater than or equal to 0. Okay. So in reality, there's really not very many operators. Like, for example, this square root is an operator. And I don't, if you'd like me to make a video about operators and like what the different ones are and why I'm using that word, I'd be happy to. But there's not very many operations or operators that have limited domains or that don't work on very many things. It's really a small list, and I'll make the list for you right here. So let's see. Operators that limit your range. That's going to be like we already mentioned, the square root operator. And that is that you can't put negative numbers into the square root operator. And let's see, the division operator. And you probably know you can't divide by 0. So that one you have to watch out for. It'll limit your domain. Oh, said range. But I meant domain. Domain. Okay, operators that limit your domain, excuse me. So you got the square root operator, the division operator, and those are probably like the most common ones you're going to encounter in the beginning. But then there's also, and don't worry if you haven't heard about this operator yet, but logarithms. So like if you have the log of a thing, or logarithms have these different things called bases. I'll be happy to tell you about it at some point. The natural log, that's log base e, or anything like that. Logarithms, you can't take the log of a negative number. They kind of work with square roots. You can't put a negative into them. It doesn't make any sense. Those are probably kind of the biggies. Let's see, what else is there? Oh, if you've encountered trig functions and inverse trig functions, those can come up too. And like I said, if you haven't seen these yet, then you don't need to worry about it. But like the inverse sine or the inverse cosine, those kinds of functions, they'll limit your domain too. You just so you know, you can't put any numbers that are smaller than -1 or bigger than 1 into sine inverse or cosine inverse. So really those are the main ones you have to look out for. And of those, for sure, these are the main ones, like square roots and division. Most of the problems that you do for domain and range, those will be the things that are limiting your domain and range most of the time. So let's see here. I don't want to take too much of your time. Well, I can't quite tell. But maybe I'll just do like one more example problem for you. If you've got any problems, like say on your homework or something, that you would like me to take a look at and work out on a little video, I'd be more than happy to. So just let me know. But I'll just make up another function for now. And we'll see what its domain and range might be. So I'm going to use the division operator for sure. So, and I'll divide by something. Let's make it up. Let's see. I'll divide by x minus 2. And then maybe I'll use also the square root operator. Okay, so we got square root of x divided by x minus 2. And let's say, you know, your teacher said, hey, here's this function. What's the domain and range of this function? Well, we've got two operators here that might give us some trouble. Let me just point them out. This fraction is essentially a division operator, right? It's saying, hey, divide my numerator by my denominator. So it's division. And what we know about division is we can't divide by 0. So we're going to throw out any values of x that cause us to divide by 0. So in other words, x minus 2 cannot be equal to 0 exactly, which means that x cannot be equal to 2. That's the value of x that would make the denominator 0. So that won't do. The other operator that would maybe give us some trouble is this square root operator, right? Square root operator, we know it cannot take, well, it looks like I'm up on the top there. It cannot take any negative numbers. So x, which is in there, has got to be greater than or equal to 0. Okay, so these are the two things that limit the domain. Overall, then, that means that x, so I'll add these like this first of all. X has got to be greater than 0 and x cannot equal 2. And actually, this might be just fine, like just a great way for you to provide your answer to your teacher. But maybe your teacher says, hey, and also I want this answer in something called interval notation. So I'm just going to go over that really quickly, just in case that's the kind of thing that your teacher wants you to do. So in interval notation, we use parentheses and brackets to kind of indicate these little intervals, and then we connect them with these things called unions. Let me show you what I mean. So for this one, if we can imagine a number line. Here's x equals 0. This is going to be x number line. This is x equals 1, x equals 2. So for us, we can say, well, can it be 0? Yeah, it can be exactly 0. That doesn't make any of our two operators have a problem, right? I could take the square root of 0, and I can say, what is 0 divided by 0 minus 2? 0 divided by negative 2 is 0, so it's all good. So 0 is no problem at all. And I go bigger than 0, and that's just fine. Like, for example, 1 works fine. Square root of 1 is 1. 1 minus 2 makes sense. That's negative 1. It's 1 over negative 1. That's all negative 1. Great. 1 works great. And we don't have a problem until we get to 2. And we can't do 2. So I'll put an open circle there. And then kind of like fill it in here. Now this isn't interval notation, but I'm just doing this so that you can see what interval notation is like. And so you kind of fill these in. So that's just a number line to help us visualize the solution here. Now, here's the interval notation. We basically have these two, we have these two intervals. The interval from 0 to 2, and the interval from 2 to infinity, okay? And we can indicate those intervals pretty easily. Here's how it works. I'm going to put a bracket before my 0. The bracket means that we're including that number. This is filled in circle, meaning 0 is included, and that's why we have a bracket there. And then we put a comma to wherever the interval stops, and it stops at 2. But we're not including 2, so I'm going to put in a parentheses. Remember, the parentheses means, hey, we're not including that. And that was, you can see the open circle, right? That open circle indicates that 2 is not included, right? And so that's why the parentheses is there. Parentheses means not included. And then we'd put a union, and the union just means like, hey, I want you to do both of these intervals. In other words, the domain is going to be 0 to 2 and this other interval of 2, again, not including 2, all the way to infinity. And here's the thing you have to remember. We never put a bracket for infinity. We never say we're including infinity. So infinity always gets the parentheses. So that's interval notation, okay? Interval notation. Okay, cool. So that was all talking about the domain, stuff that limits the domain of this function. So let me just write that out really quick. That was the domain. And we just did it in basically 3 different ways, right? That way, we did it on a number line, and showed it to you in interval notation. Cool. For the same function, let's think about the range, okay? So what are the numbers that we can possibly get out? Well, we already decided that 0, putting in 0 for x, let's see, that works. And what do we get? We get square root of 0 divided by 0 minus 2. That's just going to be 0. And I think that we also tried f of 1, square root of 1 over 1 minus 2. That's negative 1. And let's see, and then 2 doesn't work at all. And then what about like f of 3? F of 3 looks like we get square root of 3. That's an irrational number. It's kind of a number with a bunch of decimals. I don't know what it is. Let's see, 2.1 something or other. But then divided by 1. So this is just whatever the root 3 is. So let's see, we went from 0 to negative 1. Now we have some positive values. Now this one, it's a little bit funny of a function, right, how it looks. And it's not obvious to me exactly what it looks like. So here's what I'm going to do. I'm going to graph this, and then I'll show you how to evaluate the domain and range by looking at the graph. Let's take a look. I'll just pull up, see a grapher here. Add a graph page. And let's see, we had the square root of x divided by x minus 1. All right, let's see what that looks like. Okay, check this graph out. All right. So we can see the domain and how it got limited. So you can see there that there really is no red line over there to the left of 0, of x equals 0, just like we had predicted from our algebra. And we can see also that it seems to kind of go down to infinity when x is equal to, oh, I graphed the wrong one here. I graphed divided by x minus 1 when the problem I originally gave us was divided by x minus 2. Okay, we can see how that changes. Perfect. Now our asymptote, that's what that vertical line that both lines approaches is called. Our asymptote is now at 2, where it was before. So we can see clearly our domain. That's great. And we can actually kind of see our range pretty easily. We can see that we can get any value that we'd like out for y. We can get 0 out by putting in 0, and we can get any number lower than that by approaching 2, and then we can get really big numbers out by approaching 2 from the right-hand side, going back the other way, and then we can get numbers that are like less than 1 out by putting in pretty big numbers for x. So it looks like our range for this is all real numbers, and it really helped to graph it. It was actually really easy to see with a graph. Kind of like our x squared plus 3 was pretty easy to see with a graph. Anyway, so let's go back. I'll write down the range real quick. Range, we decided we could get all real numbers for the range. Cool. Now, just to remind you, I'm doing this to answer questions, doing this to see if I can put my tutoring out on the web and make it useful to a lot of people. So if you've got any questions, I'd be really happy to answer them. Just give you some free tutoring, and I'm sure if you've got that question, a lot of other people have got that question too. So please throw it down in the comments. Yeah, so I'd be really, really happy to hear what you have questions about pretty much anything. I tutor in math, science, test prep like SAT, ACT, GRE, or even the ASVAB. That's what you take if you thinking about going into the military, or you're in the military and you want to get a different position. So I tutor all those things, and I've tutored for like about 12 years, and I'd be really happy to answer any questions that you have. I do have a website too. It's just Trevor Ingman, trevoringman.com. That's me. I'm Trevor Ingman. So feel free to go there and check it out. And do please comment if you have any sort of questions. I'll answer them and I'll hit you up with the answers. Okay, thanks very much. See you.